Good morning, everyone. So here are your notes for 10.4. The title is Solving Quadratics by Square Rooting, and I will post this on your Edmodo account so you can access this after the substitute shows you. All right, first step. So here's kind of the rule. You've learned how to solve quadratics by factoring. You've learned how to solve quadratics by graphing. And this is a third method. Now this method is only used certain times, and I'm going to put a little asterisk. This method is used if there is no middle term. So if there is no middle term, what I mean by middle term would be, x to the first power. So a 2x, a negative 3x, etc. Right? So if it's just the x to the first power, if there's no middle term, then you can use square rooting. And you can use square rooting method. I guess we should say the square rooting method, but to be more grammatically correct. Okay, so here's, I just have a series of examples to show you. So here's example number 1, where you're given 3x squared equals 27. Now this is a quadratic due to the fact that x is squared, and instead of trying to factor this, which you could try to factor this, one way is to just try to isolate your x squared. So we would isolate the x squared by first dividing both sides by 3. We divide by 3 and we get that x squared equals 9. And then at this point, let's stop and think. This means that some number times itself gives you 9. Now we know that what we're going to do is we're actually going to do the opposite of squaring, and the opposite of squaring is square rooting. Now when you take the square root of both sides, x could be positive 3, right? Because positive 3 times positive 3 is positive 9. But x could also be negative 3, because negative 3 times negative 3 is positive 9. So when you take the square root of both sides, you will end up with a positive and negative answer. So sometimes you'll see it as plus or minus 3. That's a way to write it in a little bit cleaner and simpler form. Okay. So let's try another example. So example number 2. We have, let's do p squared plus 12 equals 12. So again, our goal is to isolate the p squared, or variable. So we're going to subtract 12 from both sides. Oops. And we get p squared equals 0. This is absolutely fine. We can take the square root of both sides. And it's saying what number times itself gives you 0? Well, 0 times itself is 0. Okay, and remember, 0 is a number. So we need to make sure that we keep that as an answer. Okay? Example number 3, a squared minus 3 equals negative 4. Again, isolate our a squared. Do you see we have no middle term here? We have no plain x's. So this is one where we would not try to factor. We're going to add 3 to both sides. We get a squared equals negative 1. And when we go to take the square root, right, the square root of both sides, the question becomes, what number times itself equals negative 1? And the correct answer is there's no real number that when you square it would come out as negative. So at any point, if you have a squared equals a negative number, this is no solutions. Which means that if you were to graph this thing, a squared equals negative 1, or even a squared plus 1, that would be above the x-axis, so there would be no x-intercepts. And keep in mind, that's what we're finding here. These are the x-intercepts for these quadratics. Okay, I have 2 more examples for you. So example number 4, 25x squared equals 49. First step, isolate the x squared, so divide both sides by 25. We get x squared equals, now 25 does not divide evenly into 49, so we can leave that as a fraction. Take the square root of both sides, and legally, you can square root them individually. So we have x equals plus or minus, right? Because it's a positive or a negative times itself gives us this. The square root of 49 is 7, and the square root of 25 is 5. And our answer is a fraction, which is absolutely fine. All right, the last example that I have for you, it looks a little bit different. So example number 5, and this is the end, looks like this. 4 times the quantity of x plus 6 squared equals 32. Now this you need to unravel kind of in the opposite order of PEMDAS. So the first step is we want to get rid of this multiplying by 4. So we're going to divide by 4. We'd be left with x plus 6 squared equals 8. We're then going to take the square, get rid of that squared, and the opposite of squaring something is square rooting. So we're going to take the square root, and we're left with x plus 6 equals plus or minus the square root of 8. Later in this year, I will show you how to simplify that square root. Now, there's no whole integer or integer that has that. When you take the square root of 8, you get an integer. So we're going to leave that for now. And then we subtract 6 from both sides. Now remember, you can't break into a square root. So we're going to leave this as negative 6, right? That's a subtracting 6. So negative 6 plus or minus the square root of 8. And we're going to leave our answer like that. I know that looks kind of new and scary to you, but we'll be getting much, much more comfortable with that as we move forward. All right, have a wonderful rest of your week, and I'll see you guys on Monday.